In Chapter 8, Lessons 8-5 and 8-6, we're talking about exponential growth and decay. There's two types of exponential growth and decay that we talked about, and we did a flip chart for both of them. So first, let's just talk about in general exponential growth and decay. So when you have an exponential growth function, that means something's going to be growing by a ratio or a factor. So it's going to look something like this. So it starts out growing very slowly, but then it's going to start increasing and increasing more and more rapidly. So this is an exponential growth equation graph. And then your exponential decay is going to do the same thing, but it's going to decrease or decay at a really fast rate at some point. So it'll start somewhere around here, depending on what your equation is, and it's going to go down from left to right. So this one is exponential decay. Okay, so these are our two types of exponential functions, growth and decay. Growth is increasing from left to right, decay is decreasing from left to right. The graph can move up or down based on what your equation is, but your general equation for an exponential growth and decay equation would be a times b to the x power, where a is going to be your starting amount, or your y-intercept. Same thing. Okay, so the y-intercept, let's say that this is at 1. If that's at 1, then your a value would be 1. If this is at 2, then your a value would be 2, and so on. Then your b is called your rate of growth or growth rate or decay rate. So rate of growth or decay, depending on what type of equation you have. Okay, and then the x would be kind of, if you're talking about a real world situation, usually this would be the amount of time or the time period that we're talking about. In this case, it would just be the x value for whatever point you're talking about. So for example, if I'm talking about this point right here, my x would be 0, and my y value then would end up being 1, because if I put a 0 here, that equals 1, and your a is already 1. So y equals 1 if this is your ordered pair. But this is just a x and a y value. So if you were to make a table, you could do x and y values there. Okay. After you have your basic equation, there's another type of equation, and this one would be if your exponential growth rate is a percentage. Okay, so still this is going to be your starting amount or your y-intercept. But this time, inside the parentheses, we have a growth or decay rate, but the way that we're going to write it is 1 plus if it's growth, and then the rate as a decimal, or as a percent, as a decimal, and then if it's decay, 1 minus. So this is the growth or decay rate. You're going to use this one when your R is a percent, and you're going to use this one when your B is a number. So it could be a decimal, could be something else, but it's not a percent. So before we actually plug it into the equation, we would have to change this percentage that they give you. Like if you say it's 10%, we would have to change that to a decimal first and put 0.10 where the R is. But we'll talk about that in just a minute. Okay, so this is in general your basics. If your equation is growth, you're going to use plus. If it's minus, you're going to use decay. If it's decay, you're going to use minus. On this one, in order to tell if it's growth or decay, the b value is greater than 1 for growth, and it's between 0 and 1 for decay. So for examples, let's give a few examples here. So if I have the equation y equals 3 times 2 to the x power, I know this is, first of all, a growth equation because my b value is bigger than 1. And I know that the y-intercept is 3, or the starting value. Okay, so if I were to do a table for this equation so that I could graph it, I'm going to go ahead and start at 0. So I know that 2 to the 0 power is 1 times 3 would give me 0, 3 for my y-intercept. At 1, 2 to the first power is 2 times 3 is 6. And this should double every time. So then 2 should be at 12. So 2 to the second power is 4 times 3 is 12. And then double again. So this one should be at 24 because this rate here is how much it's being multiplied by in the y values every time you go up 1 in the x. So here again, 2 to the third power is 8 times 3 is 24. So you can see that our table here is increasing. Okay, if I were to do just a quick graph, let's do this by maybe 5s, 5, 10, 15, 20, 25. Okay, then I would have a 0, 3, 1, 6, 2, 12, 3, 24. Okay, so you see it's going up from left to right. And it starts out increasing slowly because they're doubling small numbers, but then it's going to increase really fast because they're doubling bigger numbers. So the farther along you get, the faster it's going to increase until it looks like it's going vertical, but it's never actually going to go vertical. It's just going to look like it is. And this one will never actually touch 0 because if I go backwards, it's just going to keep dividing by 2, but if you start with something, you're never going to get to 0. So this is going to get really close to 0, but never actually get to 0. So this one is a growth equation. If I were to do a decay equation, it's going to look similar. So a decay equation though, let's say we start with 3 again, but this time we're going by thirds. Okay, so we said the decay equations have a number that's between 0 and 1. So 1/3, I can tell that is a decay equation because 1/3 is between 0 and 1. So fractions or decimals that are smaller than 1. So if my growth rate or what's being raised to the x power is like 0.54, this would be a decay equation because it's smaller than 1, but bigger than 0. Okay, so then here again, if I were to graph this equation, I'm going to go with 0 because 0, anything to the 0 power is 1 times 3. It still has a y-intercept of 3, but now instead of increasing, it's going to decrease by 1/3, so it's going to divide by 3 every time. So 3 divided by 3 is 1, and I can put that here. If I have 1/3 to the first power, I have 1/3 multiplied by 3 equals 1. If I pick 2, 1/3 to the second power would give me 1/3 times 1/3, which would give me 1/9, but then I multiply that by 3 and I would get 1/3 again. So this is going to be 1/3. And it's just going to keep getting smaller and smaller. So if I divide by 3 again, I'm going to get to 1/9. So on this one, I have 0, 3, and then 1, 1, and then 2, 1/3, and 3, 1/9. So as you can see, it's getting smaller and smaller. So it's going to go towards 0, but it's going to keep dividing by 3 every time. So 1/27th, and then it's going to keep going. So it'll get really small, but not exactly to 0. So that's essentially what your basic functions are here. And then the other thing that you would have to do according to 8-6 is there's some word problems in these that have percentages. So let's just take a look at one of them. So if number, we're on page 522 here, and if number 1 says, Miss Hidayah received a job as a teacher with a starting salary of 125,000 AED. According to her contract, she will receive a 1.5% increase in her salary every year. How much will she get in 7 years? Okay, so you can see that the growth rate here, we know that it's a growth rate because it says increase, and it's a percentage. So we're going to have to use that other equation that we were using earlier, the y equals a1 plus or minus r to the x power. So when we fill in the information from this word problem here, we know that the percentage is your r. So r equals 1.5%, but in order to put it in the equation, I need to change it to a decimal. So I'm going to do 1.5 divided by 100 because 1% means divided by 100 or per 100. So as a decimal, this is 0.015. My A value is going to be the starting amount. So she starts at 125,000 dirhams. So my A is 125,000 dirhams. And then my X is going to be the amount of time. So my X in this particular case is 7 years. Okay, so when I write my equation and solve, my general equation would be 125,000 times 1 plus, because it's growth, 0.015 to the x power. Now, because I want to find a specific year, I'm actually going to put 7 in here, and then I'm going to type it into my calculator. So in my calculator, I've got 125,000 times 1 plus 0.015, and then I'm going to do to the 7th power. Okay, so she's going to be making 138,730 and 61 dirhams in 7 years, because she's getting a little bit of an increase. So she's going to increase by 1.5% every year. So it should be bigger than the original salary, but not a lot bigger, because 1.5 is not a very big increase. So that's essentially what you're doing. If it's a decay problem, you're going to do minus here. So there you go. That's it.